Yeah, I might have to give you host permissions.
Okay, shall we get started?
Yeah.
Yeah, I think I might need permission to share screen.
Okay, let's see how we can do this. All right, Suda made you the host.
Okay. Are you able to see my screen?
Yes.
So, okay, let's get started. Hello all. Welcome to the community call for March 2022. My name is Sudha. I am a PMC member of Apache Hudi. Today our agenda is brief community updates, a roadmap for the next few versions and next few releases. And then we have Alexey doing a show and tell of metadata tables, column stat index work. And then we can open up for questions. So here is an insight from GitHub page. So from last month, we have like 141 pull requests merged, 45 closed issues, and 51 authors contributing to those PRs that landed. It's a good trend going on here. And then we passed 1,800 Slack users and we reached 3,000 GitHub stars. There were two new RFCs. Well, the first one exploring compaction of log files for reducing write amplification due to full compactions that can happen frequently in merge on read tables. And the second one explores integrating into Data Hub, which is the LinkedIn's metadata platform. Thanks for all the awesome community collaborations, and a huge shout out to Rajesh, who has been the top Slack contributor this month. So he's been super active and helping a lot of users in Slack. Thanks, Rajesh.
Oh, thank you. I'm just learning along them. So I asked them so many questions to learn as much as helping them. So
that's awesome. I mean, we see a lot of engagement and you know, that drives the community forward, right? Thank you so much.
So it goes a long way, man. Like, because all of us are learning, right? Like I'm learning a ton. Even the other committers in here, we're all learning from each other. So thanks for leaning in with everybody. I'm sure lots of people appreciate it.
awesome.
Okay, let's dive into the roadmap. So this is not an exhaustive list, so feel free to check out our roadmap page. And there are JIRAs and links there for each of the items. You will see that the roadmap page is divided into three categories: transaction database layer, execution engines, and platform services. So we had our minor release 0.10.1 in Jan. We have an upcoming release early April 0.11.0. So that's already like we're looking at a code freeze tomorrow and like a voting for RC early next week. So look out for that. And then we're planning a 0.12.0 in June, and later in summer we have 1.0.0 planned. I'm really excited for the tons of functionalities that we're adding in these releases. So let's see what's going on in 0.11. We have metadata index as a Bloom index alternative. So I know Hudi has a couple of indexing scheme implementations, but oftentimes we see for large files, large amounts of files, the Bloom index can shuffle lots of data. So we are looking into implementing a metadata index that can tackle these use cases where there are large absolutes for large tables. Alexey will be presenting more on this later today. But you can check out more details in RFC 37 as well. And then we have index column support, where we support index functions on columns to generate indexed columns. We're also looking into refactoring our query side code path. Oftentimes, you'll see large projects getting rewritten several times during their life cycle. Now that Hudi has like more than like 5 or 6 query engines beyond Hive, we're looking at taking some time to revisit, consolidate our code, and provide better abstractions over the code path. So for the point 11, we have phase 1 PRs landed, and phase 2 is coming up in point 12. Then we have support for encryption. So this one we are looking to expose like support encryption for exposing Parquet files. This is primarily supported on COW table. You'll be able to see more details on D2370. Next one is non-key tables. With this, we are able to support updates and deletes on non-key columns without having to specify the primary key column, while still the primary key enforcement is taken care of automatically in the background. And then native support for AWS Glue Metastore. So, so far we have been able to sync to the Glue Metastore through Hive dependencies. So this one will start using Glue APIs directly, so to be more reliable and avoid depending on Hive style syncing. And we have Data Hub integration, which we already talked about briefly. Data Hub is a metadata platform from LinkedIn. So this looks into integrating Hudi to Data Hub. We also have call procedure commands coming up in Spark SQL. So what this does is like conveniently wraps the Hudi CLI commands and table services commands such as clustering and compaction in SQL syntax. I can look more details into Hudi 3161 for this. Okay, so for point 12, we have a couple of things going on. The record level indexing. So this comes up often in the community where people have random workload patterns and global indexes. So we don't have any better solution than HBase index or employing external indices for this. So for point 12, we're planning to come up with a record level indexing, which can tackle these sort of use cases, which will otherwise require an external system. And the idea is to tackle any sort of an update pattern in a performant way. And then we have Spark data source v2. So we'll leverage the Hudi read path will leverage the Spark data source v2 APIs for features such as like push down filters and the other capabilities, while the write path will use v2 and fall back to v1 in order to preserve like the Hudi right side optimization such as file sizing, indexing, and pre-combining, etc. Eager conflict detection of OCC. So currently we have optimistic concurrency control, letting multiple writers to write data and then finally check whether there is any conflict. This can be resource expensive because we let the writers do the writes and then finally check and for like any overlaps. So with early conflict detection, we're looking into see if we can detect overlaps on pending transactions early on, so we avoid spending any resources. This would leverage the marker files to detect the overlaps early on. Index timeline and infinite retention of versions. So in today's design, Hudi allows for fixed metadata in the timeline. So this is done so to avoid unbound growth and bound lookup issues, and we leverage cleaning and archival to achieve this. What we intend to do is like support infinite table versions by indexing the timeline as well. And so we can scale the metadata more efficiently without taking any hit in write ingestion or like write performances. So this will also leverage the different indexes that we have been talking about. Next is the streaming read improvements and full CDC data model support. So currently we have incremental queries that hand out like a snapshot view of latest change. And while this is useful in some way, it would be more useful if we can do a full CDC support like how DBCM does. So this work would look into exposing like the incremental queries would hand out both the pre and post commit images along with operation type and commit LSNs. More like DBCM like semantics is what is being looked for in this particular feature. And then consistent hashing based file distribution. This hash index implementation would complement the bucket index implementation to elastically scale for use cases where the Bloom filter, like false positivity high rates are happening. So we can look more into RFC 29 for details if you're interested. Then we're also looking into supporting ORC across query engines. Today we support that only in Hive, but we want to support across other query engines as well, like how we support Parquet. Presto Trino updates. We have updated Hudi version to the latest, where metadata based listing can be leveraged, and I think this is closer to landing. And we have a Presto connector coming up that is on par with the current implementation of the integration with the Hudi, Hudi into Hive connector. We also have a brand new Trino connector up for review, which supports read optimized queries in COW tables and snapshot queries and read optimized queries in merge on read table and snapshot queries in COW table. So if you're interested, please take a look, test out the patches, and give us feedback. That'll be awesome. And then we have Mutable CDC stream support for Kafka connector sync. So currently we have Kafka connector sync, Kafka Connect sync supporting only append only use cases. We are looking into adding support for CDC stream use cases as well with this feature. And then BigQuery Snowflake external table support. So Hudi has a meta-sync mechanism where it can sync the table metadata to different services and catalogs. So we want to extend this support so we can query Hudi tables from other warehouses as well. We have already an implementation along the same lines with Redshift with AWS Glue. So we're looking to also do this across BigQuery and Snowflake. I think the PR for BigQuery is already up. We have to review that and land that. And also we're expecting Snowflake PR to be implemented along with 0.12 release. And you will also see more integrations in 0.12, such as AdByte Sync, Apache Pulsar, and Kinesis DynamoDB CDC. We have a few big rocks going on and plan for 1.0.0. We really look forward to the community to give us more feedback and tell us what you think. Here are a few items. It's not exhaustive. As again, please check out the roadmap page. First thing is the Meta server. We have like today, Meta server is like a medley of services with different external services for different purposes, like HMS for table schema and partitioning, Zookeeper for locking, etc. We're looking into bringing up a Meta server as a one-stop solution, which will be running on Kubernetes and serving timeline table metadata, locking APIs more efficiently. Next one is the caching implementation. We are looking into implementing a caching layer that can be transaction aware and can support snapshot queries on merge on read tables, which have the need to constantly keep merging. So this caching implementation would also build on the multimodal indexes that we've been talking about. And then we have lock-free concurrency control. Take a look at Hudi 3187 on how this is achieved. We are looking to leverage transition time to achieve this. And then we have we're expecting to add more cloud native ingestion support. So already we have a Delta Streamer source for observing change notifications and from S3. So this work would extend that to other cloud stores as well, such as Azure, GCS, etc. That's all about roadmap. And this is in case you don't know or looking for ways, this is how you engage with our community. Message us in GitHub, like drop by in Slack. You will find a lot of users engaging there, asking questions. We have a mailing list that you can subscribe to. And yeah, please check us out and let us know what you think. I'll pass over to Alexey for his showcase. Over to you, Alexey.
Thank you, Sudha. Sorry, yeah, I think I forgot to update the slides here with a sample. Anyway, let me see if I quickly can click on. Do you want to continue sharing? Yeah, that's fine. That works. Yeah, sorry, we will have to have the presentation with it here. I hope by the end of the presentation I can quickly grab a quick sample to show off what is the actual column stats is. All right, so just quick recap what the sorry, can you go back? What the column stats is? Yeah. So metadata table, I'm assuming like most of you folks are familiar, but just quickly recapping what this is. Basically, metadata table consolidates all the meta information about the data store inside the .Hudi folder as the Hudi table. One portion of this meta information is a column stats index. Basically, column stats index is the way for us collect meta information about each column in each file, such that we can leverage that when we do queries. For example, can you go to the next slide? For example, when we do data skipping. So what is essentially data skipping? Data skipping is a technique that leverages statistics stored in the column stats index of sort in different systems in a way that allows us to prune the search space by eliminating some files with the data completely from the search space based on the merits of deciding whether this file might contain the values we're looking for or not. For example, if we're looking for a column A containing null values, we can simply check the statistics that says how many nulls does this column contain in this file. And for example, if it says that this file in this column contains no null values, we know that we can completely eliminate this file. This file does not contain any values that are of interest for us. Why does it matter? It matters because collecting a representative set of statistics, like for example, mean value, max value, null counts, and some more, we're able to very efficiently and very effectively prune the search space, and allows us, coupled with other layout optimization techniques, like for example, clustering and partitioning, it allows us to bring much desired savings of resources like time, compute, space, and so on and so forth. Next slide, please. Yeah, just to showcase you how this works in the upcoming release 0.11 with a new upcoming constants index, which is going to be an experimental mode, as well as with data skipping that was enabled in 0.10, along with the introduction of special curves and interclustering. Here, as a test bed, we have an Amazon reviews data set bearing around 160 million records, 160 bytes each. Overall, all in all, this data set is taking up about 32 gigs. We started as a Hudi table, COV Hudi table. We deliberately kind of squashing the file size to blow out the table to 40,000 files. This will leave us about like 1 megabyte per file. This is not like the real use case scenario where you'll probably you should not be storing like files of 1 megabyte in size, but here, just for the sake of showing like how this is gonna scale with the number of files in the table. We're specifically blowing out this number. The table is also partitioned by year. All of that is being tested in AVS EMR with one master tree executors with an M5 X large node, which is pretty standard. Next slide, please. Yeah, so we run just the two very simple and very straightforward queries. Query 1A. Both of those queries are point lookups, or basically we're just searching for a record with a single condition. The difference between those two queries is the first query is kind of searching the record, which is kind of among all the files. It's more probable to be in most of the files, so it kind of has to search more files. The second one is very specific. It can the possibility of it being contained in a file is very low, so it's high specificity, and only a handful of files contain it. So as you can see, query 1A with data skipping off takes about 660 seconds, which is in total about 11 minutes. So it took us about 11 minutes to scan 40,000 files. And as you see, it is consistent across both queries, which is in line with our expectations because we scanned the whole table, we read all the parquet footers, so that is expected that in both queries, we actually scan about the same amount of data. Now, when we enable data skipping on 0.11, as well as, obviously it's not called out here, but we also have to enable call stats index as well. With those two enabled, we see that query 1.A is now taking only 120 seconds, which is about 5x faster than without data skipping. Out of which about 55 seconds I think, yeah, Rajesh was asking to let somebody in. Can we help somebody? Yeah, so out of those 120 seconds, about 55 seconds it took us to read the metadata table itself. We're looking at ways to optimize this even further to make sure that it's as nimble overhead as possible. And just to put things in perspective, with 40,000 files in your data set and with a data set bearing around 20 columns, with all of them being indexed, all in all, we have around 850,000 records in the metadata table. So just to a little bit put things in perspective a little bit and help you understand why it's taking 55 seconds to read the metadata table, column stats index. Overall, the scan itself, basically just scanning the data files, took around 65 seconds. So we scan about, I didn't remember the exact number, but I think it's between 5 and 10% of the files. So as you can see, it's in line with our expectations. So to scan 10% of the data set, it took us 65 seconds, while the whole data set is around 660. So moving on to query 1B, with data skipping on, it took us to execute it about 66 seconds, out of which 60 seconds again metadata table, which is consistent with the query number 1, or 1A, and the scan itself took us only 6 seconds. So in that case, we scanned very minimal amount of files, so just about 1% of all the files we have, and overall it yields a 10x better performance with data skipping on as compared to without. Next slide, please.
Yeah, Alexey, one question. So
go ahead.
Since it's taking a lot more time, can you go back to the previous slide? The 60 seconds on the planning phase, if you may. When we introduce the meta server and if we can cache it, will that make it any faster? Is that what you're saying?
Yes. So introducing of caching and meta server will help a lot here. But I think even before that, we'll try to spend some time and effort to actually optimize it. I think there's a lot of room for improvement, because even though we're scanning a lot, there's the metadata table itself with column stats index and just the column stats index in that case takes up about 65 megabytes. So you can imagine scanning 65 megabytes, merging all the records, is going to take some time. I think we still can make it much better than 60 seconds for sure. Especially when actually no real merging is happening. We just need to read, deserialize, and kind of process those records. But dwarfs as compared to the full scan of the table, which is going to be, scaling even further linearly with the number of files you have.
Okay, and if this is Spark SQL, basically the plan phase basically for the query is where that the empty time will be spent, right? And then the execute is where the scan or looking at the files.
Sorry, you didn't catch the last part. Can you repeat it?
And this is more you're using the Spark API, right? But if you use like Spark SQL, we will hit the meta table. The column starts index during the plan phase, and then that returns the files to be scanned for the execute phase.
Kind of. Yeah, you can think of it this way. Yeah, basically, we own quite substantial amount of the Spark SQL stack in terms of providing our own relations, which is a common denominator of defining the tables in Spark, and also like the RDDs and stuff, and all of that is has a bespoke implementation Hudi, which we kind of like cater for and optimize on. So yeah.
Okay, I'll check it out.
Next slide, please. And just to quickly exemplify you with some metrics from the AVS regarding the bucket access. So all of that was stored in S3. As you can see on the leftmost in the leftmost corner, the number of requests that is being issued to the bucket for query 1B, which is scans about just under 1% of the files, is very minuscule. You can't even see it compared to the scale of the query without data skipping. So it's just hundreds of requests as compared to thousands of requests for the same query without data skipping. The amount of requests is actually surprisingly much larger than the size of the table itself. So as you can see, it goes up to like 30,000, and it sustains in there. But this includes all requests, including head requests, including get requests, so on. But this like also takes up like for prolonged period of time. So I think there is a sort of the issue of like how AVS depicts these metrics, but keep in mind that like it's not that it continuously like fetches 30,000 files like every second. It's a dot plot which has the dots connected, and that's why it looks like that.
Hey, did you hit the S3 throttling issue with the number of requests you can do per second when you did?
Yeah, that's a good question. So we didn't hit the throttling issue here. You can see like on the right side that like there was a small blip of like 500s, but it's fairly minuscule. It's just like in tens of 500s we hit. I think that one of the reasons why we didn't hit it was because we have fairly modest concurrency. So we only had like 3 executors. I think as you scale your cluster to have more executors, it's more likely for you to hit it. Also, it depends on like what configuration of the table.
Yeah, how many prefixes you have and all that.
Yeah, how it is partitioned, like how big are partitions and whatnot. So all of those play a role. So for example, we also ran the test when we did the same exercise on non-partition table. Basically, when you don't have the shared prefix where all the files have a random prefix, and that way you don't even hit the throttling. It's going to be really hard for you to hit the throttling. But for partition tables, it's more likely to happen. But again, I think it's going to be, you need to push in either direction of concurrency or the size of the table even more.
And what did you use to build these graphs?
These are just the widgets from S3. You can build it in CloudWatch. They're fairly standard. Yeah.
Awesome. Thank you.
Yeah, and just to wrap things up on the query 1A, you can see that again, same goes in line with our observations before, that query 1A with data skipping on has some blip of like requests shooting up because we scanned about like 10% of the data set, but it's quickly diminishing as compared to the same query without data skipping, which is sustaining at large amount of RPCs being issued to S3. Yeah, same goes for ingress egress. You see that queries with data skipping read only the data they're actually going to be using, or to put it differently, on the data they cannot unfortunately prune or like eliminate from the search space, so that they will have to check. Otherwise, we see considerable reduction in terms of ingress, egress, compute being used and whatnot. So overall, I think the metadata table will have a substantial improvement in performance on the medium to large scale of the tables and Hudi going forward. Yeah, I think that is about it. Sorry, I didn't put in the sample of the table. I will backdate the update retroactively the slides so that like whoever will be looking at the slides will have a glimpse of what the table looks like. Sounds good. Any questions so far?
So if we want to try this out ourselves, where is a good point to start?
That's a great question. I think I will also add the slides with the pointers like how to do that. But basically, if you don't want to wait for point 11, you can do it on a snapshot already. You'll just need to enable column stats index and enable data skipping.
No, I mean, on the data set that you had, the Amazon reviews, if you want to use that and test this out. Is there?
Yeah, you can do that on Amazon reviews. You just ingest it with data, with the column stats index enabled, also metadata table enabled. And then whenever you issue a query, also keep in mind that this is only working for Spark SQL for now. When you issue a query, also specify that you want to have data skipping enabled, and then you should be able to see it.
Awesome. I'll wait for the try it out.
Sounds great.
Cool, Alexey.
We open for any other questions.
So I guess the next step for that one, Alexey, is to kind of test this alongside of Z ordering and clustering, right? So that the stats are more effective and kind of pruning a lot more files. Is that, or did you already do that with your testing?
Correct. So we actually did that testing with when Z ordering and Hilbert was introduced last major release. So basically, when we were testing back then, we didn't have the column stats index implemented within metadata table itself. So we kind of had to build, scramble and build a bespoke implementation, which was just like storing the in a similar layout, but it was storing in the Parquet files in a separate folder in the Hudi folder. Now all of that is consolidated within the metadata table. So I didn't think we were planning to sort of put out a separate blog post because it's going to be heavily overlapped with the blog post that we already had regarding the Z ordering and Hilbert. But your hunch is absolutely right that like all of that is coupled with other layout optimization techniques, and they're more efficient. For example, when you cluster by the column and basically make sure that the spans or ranges in the files persisted are not overlapping, the higher the chance that they're not overlapping, the higher efficiency of data skipping is, right? So if we would imagine that all the files have exactly the same ranges, then data skipping is practically useless because it will not deduce any meaningful information from the ranges. I'm sorry.
Awesome.
Yeah. So using all of that coupled with the clustering and, for example, using some sophisticated ordering techniques like Z order or Hilbert is the way to go to like optimize your query side performance even further.
Okay. And I have one question that may not be directly tied to the column stats, but let's say if you have like Bloom indexes built on a couple of columns on the Parquet, will they be bubbled up? Is there a way to bubble them up to the column stats so that those can be used for pruning out the files?
That is a great question. So right now, data skipping isn't relying on Bloom filter directly. So it's actually Spark who is relying on Bloom filters. So I think there is a plan to. I'm actually not sure. I think Sagar can give us more direct answer in terms of like what is the state of Bloom index in terms of is it released in 0.11. But long-term wise, yes, if we bubble up the Bloom index inside metadata table, we can absolutely use it in data skipping to roll it out even further.
Okay, I'm not talking about the key level Bloom index, but I'm more about like have secondary indexes or other columns that we build Bloom indexes on.
I see. Yes, we can use that as well.
Okay, that would be like secondary indexes, I guess, when that happens.
Yep.
Awesome. Yeah, cool stuff.
Yeah, just to add more on that. So once we have Bloom index for secondary keys, which we plan to have in the next release, in the data skipping path, the flow would be something like you do a range pruning based on column stats, and then go ahead and do record pruning based on the Bloom filter index. So that would definitely help in data skipping.
Awesome.
Maybe Sudha, maybe you can flash some of the roadmap slides again and see if there's other questions from folks on here.
Yeah, sure.
I didn't understand the multi-model indexing. What does that mean? Does anyone know? Maybe. Or is that what I heard? I heard multi-model a few times when Sudha showed her slides. Is that like where we're indexing several different ways, like Bloom and other ways, or?
Yeah, essentially that, right?
Okay. And then you pick the right index based on the workload?
Yeah. Sorry, Sudha, go ahead.
No, please go ahead.
Yeah, to pick the right index on the workload, do you mean like
maybe I think what
from
indexes do we
intelligence?
create? I'm just guessing at this point. I don't. So when you say multi-model, you have different indexes, right? What are the different indexes that are possible other than Bloom?
One is the files listing index, then column stats index for range pruning, and then Bloom filter index. Those three.
So,
yeah.
I guess in this case, you will utilize all of them, or
yeah,
right. Yeah.
The idea is to introduce a holistic portfolio of indexes that will be covering, like, most aspects of both write path and as well as the read path.
Sorry, I didn't understand. What were you saying, Alex?
Yeah, I was saying that the idea is that the indexes, that multimodal index, which we kind of use as a collective name for it, will have a portfolio of different indexes to supplement different flows of Hudi on the write path as well as on the read path.
Okay, got it. Native support for Glue, that's a good one, because I think that will eliminate like lots of the Hive jar dependencies and Hadoop issues. So I guess if you're running locally and trying to hit the metastore, that will, or even on Hadoop.
Yeah, I guess that would become even more reliable, I guess, using the APIs directly.
Yeah, is that, when you say API, is that like a REST API? I have never used Glue APIs.
Yeah, those are REST APIs.
Awesome.
There was one you had, Sudha, that was about the Spark v2 data source. Is it on the next slide or was it back?
I think it's planned for 0.12.
Just v2 to fall back to v1. Okay, yeah. Does someone know? I haven't studied that. I know Spark data source v2 is like a generic Spark thing as well. What the benefits are like when we have the v2 support here, or is this, or are these tickets more about like the improvement of in between v2 v1?
Yeah, Raymond, do you want to talk more on this?
Yeah, it just make more use of the v2 API for improving the reads.
Okay.
Like the predicate push down, such features will be well available from there. And as it says, like this is more for improving the read, and then the writing is gonna fall back to v1. Actually, this is already implemented in in 0.11. I think in 0.12, we'll just building on top of V2 and improve the read.
Okay.
Yeah.
Curious to hear also, Rajesh, you've learned a lot about Hudi this last month. I can't remember how long ago you joined up, but you've been moving fast, learning fast. Are there other things that you've seen, other patterns or like common asks or roadmap things that you've seen?
I think a lot of them were covered. I've seen a lot of issues come up on basically the inefficiency of Bloom filters, where people are trying to do, upserts, and now they would take a long time to do the workload profiling to figure out how many base files to pick and where to kind of push those writes and upserts. And second is against having a lot of issues with like just the general version matching between like Scala, Spark, and all that. And it looks like people went through those pains. But I saw lots of issues in the past on Google. I'm seeing some of those, and looks like the merge on read table. I saw some folks that are trying to like turn off compaction because it's kind of interfering with their write ingestion. And that's not enabled. I think Shiva and I was talking, we were gonna explicitly enable that. That way they can deal with that in a separate flow. Right now there's a way to compact, but there's no way to like plan it and leave it at that. As soon as it sees it as an MOR table, I think it does either inline or async. There's no way to like delay that to a separate process. Yeah, I think that's one. And yeah, lots of users on AWS with the EMR that are showing up. Yeah, I think I'm just still trying to kind of go through some of the code, but looks like that's where the issues are with. I saw like one guy from Grofers who has hit this S3 limit on the, I guess he's been throttled by S3, and he saw some exceptions in the log. He might benefit from the stats, the column stats.
Oh, cool. Using the general channel.
Yeah, I think I was replying to him a while ago and asked him to file a GitHub issue. Don't know if he filed or not.
Cool.
Yeah, but I think
I think just going to add like the call procedure commands would also be very useful. I guess like.
Yeah, I think it would be nice to kind of maybe like showcase this with like a small, like a notebook with SQL magic, that way people can experience it really easily.
Yeah.
I know everybody's busy, but that way they don't have to go fire up a Spark shell.
Yeah, I think that would also be a good show and tell for the next sync.
Yeah, like fire up like a Docker image and bring up a notebook and show how to run. Lots of people have issues with like installing Hudi CLI in places other than EMR. So I think this will be good for them to kind of be able to kind of get to it from a different place. And you can add comments and all that in your workbook as they're running those things.
Yeah, that'd be great.
Yeah, I think it's a good idea for a notebook, but also in terms of the metadata table, what we've discussed today, I think we're gonna roll out a blog post after the 0.11 release, which with all the references and code snippets, so that like everyone is able to reproduce the same results we're getting.
Yeah, lots of detail there. It'll be good to demo that, kind of show it in action basically, and then have people try it out, because people will obviously run into issues because not everyone looks at the source code and they know the history and the knobs to turn.
That's true.
Cool.
Awesome. Thanks, guys. I will drop and nice.
Thank you so much, Rajesh.
Yeah, bye.
Thank you, everyone.
Yeah, thanks, Shiva. Thanks, Alexey.
Thank you, folks.